All right. If statements, decisions, decisions, decisions. Every day you make lots of decisions. Either you go to school or you don't. Just like Yoda, do or do not. There is no try. Either you do something or you don't do something. That's how computers think. They don't try, they either do or they don't. So computers are like Yoda. We have a variable, which is a storage place in memory where we can put things. We're putting the number 1 in here, right? That's last week. Now we're taking whatever value this is and deciding, is it positive or greater than 0? Okay, that's interesting. I don't know why I said that. Is X positive? Because that already is greater than 0, isn't it? Yeah, just a second here. Let me put it back. Is X positive? That's what we're asking. Right? I don't know why I have that other part in there. Either a number is positive or it isn't. So if X is greater than or equal to 0, it's positive. Yes? Okay. So either it's positive or it's not. If, and I'm going to use a word here, if this condition evaluates as true, we jump into here. That's what we call it in computer programming stuff. We call this a condition, and we evaluate the condition. So when Ignacio gets up in the morning, he evaluates the condition of, whoa, those clothes are pretty stinky. I probably better put on some clean ones. So he's evaluating, should he put on stinky clothes or clean clothes? Well, probably most of the time his decision is clean, but he's evaluating things. So we're evaluating as X greater than or equal to 0. In this case, is 1 greater or equal to 0? Is that true or false? True. Computers do everything with true and false. 0, what? Oh no, 1 and 0. So this is going to print what? And by. Why is by printing? It's outside the statement. So Python groups things together by indentation. If this is indented in, it's part of this. If this is not indented in, it's not part of that. It only goes in here if this condition evaluates as true. All right, well, let's look at the next step. Because what happens if it's not? Oh, I don't have the one. It should say one should here should say if else. Well, maybe I don't have a separate one for that. We'll just do it here. So either it is or wait. X is negative, right? So if it's a 1, this evaluates as true. It jumps into here. If this evaluates as false, it jumps to here. 2 different roads were taken. Which is easy if the decision either is or it isn't, and you only have one decision to make. But what if you have multiple conditions? That's the next one. Oh, why does it say LF in here? I must have wrecked some of these. Okay, so I probably did. So if it's greater than 0, we're fine. Or is what else LF is, kind of. Oops, LF. That's supposed to be else if. X is equal to 0. There. Whoops, wrong one. One of the things we don't do much of in Python is use punctuation. This is one of the few exceptions. Most of the time, our command lines don't have anything on the end. If you're making a decision, you have a colon at the end saying to Python, this is a decision. Everything after this is going to, that's indented, is going to take place if this is true. What if this is not true? Where do we go next?
So another condition.
Right here, we go to this one. We say, okay, well, if x isn't greater than 0, then maybe x is equal to 0. Right? But if it's not equal to 0, what if it's negative? Well, that is all that's left. We've eliminated greater than 0. We no longer have to test for greater than 0. Think of testing or evaluating things as elimination. So once we've said if x is greater than 0 and that's false, we no longer have to test for anything above 0. That's done. We can test for 0. Once we've tested for that, we never have to test for anything because what's left? Negative numbers. That's it. There's nothing else left. So think of if statements as elimination. You're eliminating options. Do we have to have an else statement at the end? No. You can do else, elif, and then just be done. Else captures everything that was not determined prior to that. Boy, that was not a good way to say that. If it drops through all these hoops, this is the final hoop no, that's not a good one. Yeah, I can't think of a good analogy. If these are both false, else catches all the other conditions. I don't know. That's not good either. We'll go on. So we're going to go to an example of, let's see, what have I got next? Oh, temperature advisor. We'll do something close to that. Oh, here we go. Oh no, how did that get in here? It's just an MPG calculator. Let's do a grade example because I don't think that's an assignment. Yeah, let's do a grade example. There we go. So your score can be anywhere from 1 to 100. I mean, 0 to 100. So you enter your score. If your score is greater than 90, you get an A. Do we have to test for 90 again? Not at all, because we've eliminated what's above 90. If we test for this, well, you didn't get 80, so we've eliminated that. What I will see sometimes is this. Will this work? What is this and business? And is what's called a logical operator. So we're doing what's called Boolean math. Has anybody done Boolean stuff in math?
Just heard of Boolean.
Hmm?
I've just heard of Boolean, like a variable Boolean.
Mm-hmm. Oh, Boolean math, or George Boole, who invented it, means things are either true or false, which is like the basis for all computing right now. Things either are, they want us either we have a voltage or we don't have a voltage, or it's a high voltage or a low voltage. Everything is Boolean. So if we look at, if I put in a grade, for example, I put in 89. Is 89 greater than or equal to 90? True or false?
Oh,
False. So do I have to test again for 90?
no.
Well, you could. Which means I need to introduce this guy, don't I? The logical operator. This tests two things at once. So is our number greater than or equal to 80?
Oh, it's greater than.
It's greater than or equal to 80.
Yeah.
Is it less than or equal to 90?
It's less than Jesus.
So this one's true, this one's true. And means that in order to get past this, I have to have both of these be true. So that would work. It would print a B. The other logical operator is this one, or. So this means either one of them can be true, and I'll print a B. Are we going to be using ands and ors for our stuff right now? No, not really. That's for later on. But I see people struggle with making sequential decisions like this, and they'll put in this very complicated code. Because once we've tested for 90, we don't have to test again. We're done. So don't worry about those too much. Our decisions should look more, oh, I lost my grade book, didn't I? That means you guys all flunk. There we go. This is the kind of decisions we're going to make. One after the other, we think about elimination. If we've tested for 90, pay no attention to anything above that. If we've tested for 80, pay no attention to anything else. You don't have to also test to see if it's under 90 because 90 and above doesn't matter anymore. So elimination is an important concept in decision making. Because if Caleb gets up in the morning and he decides, I want to wear a black hat. Well, we don't also have to check if he's wearing a blue hat because we've already determined he's wearing a black hat. So we don't have to test for blue. Right? We don't have to test twice. So there are acronyms in programming that I'm going to introduce you to that are kind of funny too. So there's an acronym called WET. There's an acronym called DRY. This is good notes for your Ninja Notes thing. So in programming, WET means we enjoy typing. We enjoy typing, which means you do the same thing over and over again. You repeat your code, you type everything out instead of copying and pasting or making it more efficient. Dry is what we want. Do not repeat yourself. So we don't want to test for 90 twice. Those are two real general rules of programming. We don't want wet solutions. We enjoy typing. We want dry solutions where you do not repeat yourself. I have that in various parts of all my classes that I teach. And those are real things, just like the rubber ducky thing is real. Yes.
Did they have the and in there because it was an if instead of an else if?
Doesn't matter.
Okay.
Let me find that again. Where was that? Less efficient. It can be if or else if. This is another example of how now I forgot about that. I'm glad you brought that up. If you're making a decision based on one criteria, you don't ask again and again and again and again. It cannot be more than one of these. It has to be only one. And LF says only one of these, because that's another common error is to do if. We only use if at the beginning. LF, and maybe we use an else at the end. These would be separate decisions. Can you have a grade of 80 and 90 in the same assignment? No, you can't. Benjamin?
There's nothing like when the if statement like founds when it's correct, there's nothing to stop for like to not rate everything
It has to test every single one.
but that's like you have like super big amount of if statements. It can be a little bit more laggy or something like slow, like the code.
It can be long, so we break things up into chunks.
Okay.
Is what we do if we have a lot of decisions to make. We break it up into pieces, which we haven't gotten to breaking things up into pieces yet. We'll get there. So we have our code in little chunks of code that you can reuse over and over again. In this case, this is not efficient either, is it? If this tests true, we're still testing all the rest of these anyway. So how should this be? I must have changed this one too, because I was doing the same thing I'm doing now, going through and changing things. This with LF means once we find the answer, we're done. We're out of here. We don't have to test things extra. Test, true, we're done. Test, we're done. Test, we're done. If you have sequential if statements, you still have to test each one of them. So you're making extra work for the poor computer. It'll be sweating. So all of our decision structures we will be using will start with an if. There won't be multiple ifs in here. If there's multiple conditions, we'll use LF, which is like, well, if it's hot outside, I'll do this, or if it's this, I'll do this, or I'll do this, or I'll do this. And if all else fails, I'm just going to go and take a nap, which is the else one. This is optional. You don't have to have else. You start with if, and as many decisions as you have, you do else if you want to take care of like everything that wasn't taken care of here, this takes care of everything else. which is why it's called else, I guess, right? Yeah, that was weird. Yes, Ignacio.
I have a question. So, how would we like test this? Like, let's say all of us, we did an assignment. Now we come to you with a bunch of percentages. How would we like feed this whole program so that it like works in like a flowing type of,
Oh, you're in the next step, which is loops.
oh,
We'll do that next.
okay. So,
And if you had, which also you'd have to enter each score one at a time. Right now I have to run the program each time I want to test a score.
exactly.
I can do it in a loop, so it'll keep asking me for scores.
And then you just feed and feed.
Yep. Or I could put all your scores in a file and just read the file and then spit out all the answers.
Okay, yeah, see.
So we're building one thing at a time. I don't know if we do files in this class or not. There's so many things to do, you can't do everything.
Sure, okay.
But yes, that's exactly right. We don't have a loop with this yet. That's the next step.
Okay.
Make decisions. Typically, the flow is you make decisions, then you do loops. Because loops actually have decisions. So if I'm looping, at some point I have to stop, don't I?
Mhm.
Well, that's a decision. If I'm looping through 10 times, once I reach 11, I'm done. That's a decision, just like an if statement. So
Okay,
that's why typically computer classes will go from if to loops, because the if is like the fundamental thing to learn.
okay, so in the loop, we can like set like a timer and a limit and.
Yep, you could say, I want to run this bouncer program 4 times, or you could say, I want to run this program until I type no to exit.
Okay,
So there's many different ways we can decide what we're doing.
I'm assuming that's where like bugs can come in and stuff.
Oh, they could come in right now. I mean, these simple programs can have bugs,
So that's true.
you know,
Okay.
if I did this. This is a bug. Because if I type in anything under 90, it's gonna crash. Why would it crash?
Because you,
I said I want an int. Oh, this actually might work because I can compare an int to I can compare an int to a float. So we have 2 different types of numbers. We have whole numbers, we have decimal type numbers. So where I could crash the program is if I did this.
oh,
I didn't type in a whole number.
okay.
So that would be a bug in the program. Because we didn't allow for somebody not knowing what they're doing when they ran my program. Now we'll get to that too. We'll handle all those things.
All right. Is that how like also like SQL injection works by trying to crash? Like,
Or inject things into the program that they didn't expect.
oh,
SQL injection is actually pretty sophisticated. But literally, it's like putting in something that causes the program to crash in a certain way, or you're directly accessing the database from the website. And you don't want to do that.
okay.
That's the best analogy I can think of. We do that, we get close to that in like computer science 1, which is like you have to learn SQL first and all those sort of things
Okay,
before that injection attack makes any sense.
all right.
Because how we do SQL in programming is we do it to avoid that sort of thing. All right, so now we've got ifs, else ifs, logical operators. There is a thing about nested conditionals. Let's just look at that real quick. At this point, we're not really going to do much with that. We're going to stick with else, if, sorry, if, elif, optional else. That's most of what we're going to do. I want to introduce this part. So what's the grade of your first test? What's the grade of your second test? How many times were you absent? So I have 2 grades, I'm averaging them. And then I'm doing attendance. So if my average grade is above 6, but my attendance is really good, I get approved to go off campus. If I have bad attendance and my grade's good, I just don't, I can't go. So you have multiple conditions. So yes, is your brain exploding on this? I just am introducing you to it. We won't do much with this right now. Mostly we're going to work with if, elif, optional else. So let me stop this recording and we will go through a assignment Time is, yeah, we got time to go through an assignment. Now, unfortunately,